Hello, everybody. Thanks for coming. Thanks for coming on site here in Paris, and also thanks for joining in remotely. I'm Marco from Mainmatter. Mainmatter is organizing this with the Paris Rust Meetup, and we're hosted by Qonto, obviously. Thanks for that. And the goal of this meetup is kind of to talk about Rust for backend web development specifically, right? It's a space like many people are interested in, but many teams still have concerns, you know. And we want to present some like real world success stories and answer people's questions also. To explain why Rust is actually a great choice for backend web development, right? First of all, as I said, thanks to Qonto for hosting us, and I'm handing over to Emeric, CTO of Qonto, for a quick introduction of Qonto.
So good evening, I'm Emeric, I'm the CTO of Qonto. I'm very glad to welcome you all here tonight for this meetup, because I'm also a former core developer of Django, a Python web development framework. Fortunately, I quit before you started displacing me, so I'm safe, you can go ahead. And it's very cool to see a new generation coming up, and if you want to learn about a few things of about 10 years ago, how we did it, I'll be here for drinks afterwards. A few words about Qonto. We are an all-in-one finance management solution for SMBs in Europe, and I don't know why the slides don't show my screen. They should. Oh, yeah. Excellent, it's fixed. So we are providing a business banking account for SMBs, starting at freelancers and going up to companies with a few dozen people. And we are providing a range of finance services, such as finance management, managing your invoices, accounts payable, accounts receivable, managing your bookkeeping, etc., to make it just easy to run your finances, so you can focus on your business, which is what really matters, and focus on your customers. There's a bunch of numbers on this slide, which I will summarize as it's going well. And unfortunately, we don't hire for Rust just yet. We have a bunch of Rustaceans in the team. They have a Slack channel where they conspire to take over Qonto, maybe at some point. But for now, we only hire for JavaScript, Python, Golang, and mobile, Swift and Kotlin, obviously. And again, if you want to know more about Qonto, if you're curious about what you're doing, reach out to me after the meetup. And without further ado, it's time to talk a bit more about Mainmatter, maybe, and then get to the real stuff.
Thanks, Emeric. Yeah, so just a few words about Mainmatter. We're an engineering consultancy. We build web apps, front end to we build web apps front end to back end, and we mentor teams that build their own web apps, right? And so we enable them to deliver better results faster and more reliably, right? And last year, we made a strategic bet on Rust, as we see a lot of potential sort of in the language and ecosystem, obviously, for building web apps in particular as well. And we want to help teams sort of to adopt Rust, right, with mentoring and workshops. We do custom development in Rust, and we also do team augmentation, which is kind of a mix of the two, right, where sort of our team joins the client's team, and we work with them and sort of deliver what they need to deliver, and sort of on the side do like on-the-job mentoring, sort of to level up the team and enable them sort of to continue on their own once we leave. And we also, because we like Rust so much, we also organize a Rust conference called Eurorust, which just finished 2 weeks ago in Brussels. Was pretty successful. I think it's fair to say that myself. So I can't really invite you to this year's conference anymore, but you can save the date for next year already, right? So it's October. This is actually wrong. It's October 10th and 11th next year. And for this event, we work together with the Paris Rust Meetup. I don't think anyone from the Meetup is here, or if there's anyone, say hi. No? Thanks anyway for working with us. Quick round of applause, maybe. And just few words about what we have planned for today. First, we'll hear from Jeremy, who will share how Apollo rewrote a critical piece of their system in Rust, right? And so if you will talk about decision-making process and weighing of pros and cons of Rust for that, the approach they took for progressively rewriting what they had before, and talk about debugging, profiling, monitoring, and so on. And then we will have a panel with Jeremy Bastien, co-founder of Rayon, and Mainmatter's Rust expert, Luca Palmieri. And they will talk about their experience running Rust systems in production, right? The why of choosing Rust in the first place, and also the how to go about it. And you can also ask your own questions, right? Like I will be walking around with a microphone here, and you can also ask questions in the YouTube chat. And for that, you might want to take a picture of that, because that's going to take you to Slido where you can ask your questions. And we'll also put that on later on. So that's it already. Have fun. And I hand over to Jeremy for the first talk.
Hi, everyone. Jeremy here. Nice to meet you. I am super excited to be here for a bit of a weird reason. The Rust Meetup in Paris is the reason why I'm here today. And by that, I mean, because I went to such a meetup 4 years ago, or even 5 years, I don't quite remember. It got me to connect with people who were working at Mozilla back then and working on Servo. Maybe some people remember. And that's why I started learning Rust and doing open source. And now I'm working full-time at Apollo with a bunch of other people focusing on GraphQL. One of them is in the room right now. Feel free to ping him. And yeah, I'm working on building a supergraph runtime in Rust. So some very, very cool stuff with latency requirements, safety critical, mission critical for companies. It's all happening in Rust, and it's all thanks to this meetup. So I'm very, very happy to be here. Today, as was introduced, we're going to talk about rewriting it in Rust. We're going to talk about why you would choose to rewrite stuff in Rust. We're going to talk about how you can rewrite stuff in Rust, okay? Here's a couple of handles. My name is Jeremy Lempereur. You can find me on LinkedIn. You can also find me on Twitter, X, or whatever the current name is. And if you're looking for another social media, here's my blue sky down below. Hope I don't get banned for this. So yeah, let's have a look at the agenda for a second. Why we choose Rust? When should I use Rust? When should I not use Rust? And that's very important. I hear a lot of companies that says, we tried Rust, didn't work, Rust isn't good. No, that's not quite the reason. We'll dive into it a bit later. And once you decide, we're going to have a look at a couple of migration tips. How do I go from an existing code base with customers delivering value and actually turn progressively stuff into more and more Rust? And then we're going to talk about deploying, maintaining your application. What I mean by that is if you are rewriting an application in another language, you end up in a situation where you need to be able to trust the new code that uses a new language. You need to trust that the rewrite effectively behaves the same as the previous one. And you need to trust that it's not going to break production. How can I safely deploy my new application next to the old one? Okay? Let's dive. Why we chose Rust? If you are familiar with meetups in general, that's pretty much the gist of why people choose Rust. The $1 billion mistake, not here, no null, no throw. The router is not allowed to crash, and it won't. We use options and results for people who are familiar to actually deal with that. Ownership and borrowing means there's a whole class of bugs that is prevented at compile time because the compiler has our backs. Zero cost abstractions, very important. We are making no compromise here. It's not either the code is elegant, like functional programming and this kind of stuff, or it's fast. And the type system is really great. Well, with a bunch of caveats. I don't know if you've heard of GATS, for example, but we're not going to talk about those just yet. Great type system, a lot of elegant abstractions that you can use. The reason why we choose Rust in general, I see a lot of people come for the performance and stay for the safety. Rust is fast for sure, but the reason is that we prevent a lot of bugs at compile time. And what I mean by that is that this chart is pretty well known. It's actually like the relative cost to fix bugs. What I mean by that is how much engineering time and actual company time does it take me to acknowledge the fact that there's a bug and fix it. If it happens during requirements while you are basically at the drawing board saying, hey, we should do this and that, you can say, oh, no, that's not going to work because X, Y, Z. At that point, you're in a pretty good spot. You just figure something else out. It's not going to take a lot of time. When it happens during coding, it's not really great, but it's still fast. And then it's going to be more and more expensive. If another team catches it, then it has to go back to your backlog. It has to be a bug. You need to switch context. You need to work on that. It's terrible. System acceptance testing, and the worst thing is after the release, of course. After the release is basically when your customers call you to tell you that there's a bug in your software. Doesn't feel good at all. We're trying to shift left as much as we can, and Rust helps us achieve that. When should I use Rust? I used to do freelancing before I joined Apollo. Most of the places where I saw widespread usage of Rust were basically when security is critical. It doesn't happen to most of the companies, to be really honest. Like when security is really critical. In constrained systems, what I mean by that is embedded software, your headphones, for example. You don't have a lot of memory. You don't have a lot of CPU. You might as well use a language that is extremely fast and that is not going to require a lot of RAM, for example. And at scale. What I mean by at scale is that if you're cloud native, at some point, your AWS or Google Cloud bill is going to be massive. And at that point, the simple fact of rewriting bottlenecks or pieces of your stack in Rust is going to yield tremendous benefit. A small performance increase means a lot of dollars less to pay to your in your cloud bills. When should I not use Rust? Well, for the grand rewrite, I hinted at it. The grand rewrite, you know, this big project that is supposed to be exactly ISO, which is exactly just like the previous one, except better and different, but you don't have the specs, and it's going to take 18 months. And it's just not going to happen. And if you rewrite it in Rust, it might be even worse, actually, because you need to figure out how Rust works, and you need to figure out what you're building. It's going to be very hard. You're going to stop delivering value to your customers and to your users, which is ultimately what you're here for. You're not here in a company to actually have fun with the tool. You're in a company to provide value. You can't halt it for 18 months for a grand rewrite that is extremely risky and might not happen. Or if your team can spend time learning it, use a language that you are familiar with. I don't really like Go. I used to write some, but I don't really like it. One thing that I really like, however, is that it takes around 3 hours to switch from another language to Go. It's much easier to learn Go. It compiles extremely fast, especially compared to Rust, and you are in a great situation if you use it. So sometimes Rust is not the right thing to do. Okay, no one stood up, so I guess you're still here. Let's see how we can rewrite stuff in Rust then, and how we made it. Basically, what we did is an incremental rewrite. What I mean by that is that at Apollo, there was a lot of JavaScript and TypeScript. The gateway that the Rust router is replacing was written in TypeScript and JavaScript. So we used something that is called Deno, or is that Dino? Not sure. Anyone familiar with Deno? Can you raise your hand? Okay, okay. Not too bad. Which is pretty much kind of like a JavaScript runtime, except it's written in Rust, and it allows you to run JavaScript or TypeScript code. So basically, we use Deno, and we interface from Rust into JavaScript. And the deal here is that you can interface with most of the languages, and you can reuse the tooling, the libraries, and everything that you're comfortable with. It doesn't have to be a leap of faith. You can adopt it incrementally. You identify the places, and then you migrate. Most of the router functionality that I said is written in Rust. And the query planner, which is the only part at the moment that is written in JavaScript, which is written in JavaScript or TypeScript, we interface with via Deno. Okay? Here is the biggest TypeScript sin I've not written, displayed on a screen. We basically declare something. Please do not make it the any type. That's just for the purpose of the presentation. And then you use it. That's pretty much what you have in the TypeScript code. Then you have a couple of lines of code that say, hey, by the way, my hello.js file is right here. You create a worker path, you instantiate a worker, and there you have it. You're running hello from Deno directly from your Rust code. Okay? It's not too complicated. Let's do a bit more JavaScript, since that's what you're here for, right? Basically what we have here is a while true. So that's pretty much a loop. And we are receiving events that come from Rust, and we are sending responses back to Rust. That's pretty much how we write a small worker using that. And then you can use it. It's extremely powerful, and you can invoke and call stuff back and forth from Rust to JavaScript. Like I said, a couple of strategic tips. You identify bottlenecks. First of all, you need to have a reason to rewrite stuff. Then you rewrite piece by piece. The good news for us is that most of the code has been rewritten in Rust already. And now we are going to start trying to rewrite the last tiny bits. How do you trust the code? How do you make sure that your rewrite is actually doing what it's supposed to? Here's a couple of pointers. Not a good pun, is it? The first one is unit tests. Everyone familiar with unit tests in general? Yes, 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 yes. Okay, that's going to be fast. There's a second class of tests that we rely on very heavily, which is called snapshot test. Does everyone know what a snapshot test is? Okay, pretty cool. Let's have a quick look at an example if I can find it. Yeah. Here we have a couple of tests that actually rely on snapshots. The snapshot, which you can see here on the left-hand side, is the expression, the line at which it was invoked. Is that clear enough? Do you want me to zoom in a little? Is that good? Zoom? Sure. So here, this is a GraphQL schema, and it's pretty much dumped straight as a snapshot, okay? The idea is that when I run cargo test, tell me I compiled before. Yes. It's going to run everything, and everything is fine. Now, the thing is, if the snapshot changes, or if I failed my refactoring, or I changed something in the logic, the test is going to fail. And it's going to tell me exactly, like, it used to be product 2, now it's product. Was this change intentional? That's basically how you can write tests using snapshots. It's extremely useful for two reasons. Regression testing, making sure that you did not break anything when you were refactoring your code, or, for our example, that the previous code behaves exactly like the new code. Okay? But we can go a bit deeper. There's one thing that is called code coverage. Has anyone used code coverage yet? Yes, 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 a lot of yes, that's really good. There's a crate, I think it's called cargo tarpaulin. Is that spelled correctly? Pronounced? I don't know. This crate is really good. It actually instruments your tests. They take a bit longer to run, but you then get a nice output with a view, and you see all the lines that are covered by your tests. It's really nice. It gives you a view that's kind of like that. Sorry, I can't zoom, but basically you get the colors. It says that the code coverage in the router is pretty okay, except the folder, but well. And it's super useful. pro tips for that. You want to aim for 80% coverage. Hunting for 100% and hitting an old code path is just going to be a time sink. It's going to take forever. Honestly, you don't need that. 80, 90 is fine. Less than 50, 60 is a bit less, is a bit low, to be honest. And the other thing is that it doesn't prevent you from writing bugs. It just makes sure that you wrote the test that actually covers what you expected. So it's not great either, right? One last thing that is very important. Yeah, you get a rough idea. So it's just a helper. You run it once. Maybe you put it in CI sometimes if you want to. But honestly, you get a rough idea of what parts of your code base is covered, and that's it. One thing that's very important, you don't want to use it to point fingers at your teammates. It's a bad look. You are all working as a team, okay? Seriously, don't. Do not do that, okay? Yeah, he's probably going to make me pay for it. This is Geoffroy, maintainer of NUM, by the way. I hope he doesn't watch this. One of the other things is called fuzzing. Anyone knows what fuzzing is? Yay, that's amazing. So fuzzing is pretty much when you write a test, you cover the path that you had in mind, or you cover the situations that you could figure out. Sometimes there's just too many situations, and it's going to be extremely hard for you to figure out all the possible inputs that you can feed into your function. Fuzzing is a way to generate tests based on some random input and just feed it into whatever your application is. We're going to have a small look at what it might look like. So here, and I'm going to zoom a little bit as well. Here I have a router that is running real quick, which is right here. It's basically a GraphQL API, so I'm going to send a bunch of GraphQL queries in it. And I also have something else that is hidden right here, and I hide it because it's Node.js, which is the gateway, like the old code, okay? And what I do is we have a couple of fuzzing tests that here generate operations. And generating operations is pretty much the process of turning garbage or random input, like /dev/random, into a valid operation. It basically goes through all the code path. If there's like an enum or whatnot, it's going to convert whatever the input that is random is into a structure. And then it's going to feed it into whatever you want. Here, we are doing something, as you can see. We are creating an HTTP client, and we are calling the gateway. We are calling the router, sorry, and we are calling the gateway. Then we have some debug output. We are checking the response, the status codes, and we are making sure that, can I see it? File write all, file flush. So in case of error, we are going to dump it. So we actually have reproduction test cases. And we are going to check errors, and we are going to check output. That's an extremely powerful tool. And I hope I'm not going to bork my computer if I do this. You need to run nightly, if I recall correctly. And you run a fuzzer, and you're going to get a lot of output like this. And it's going to run. At first, it's going to crash almost immediately, because it's going to figure out cases you did not have in mind. So you're going to fix them. And the way it's going to do it is it's going to show you the crash, and it's going to give you a reproduction case. From the input that it has generated, it's going to dump you all the steps to reproduce so you can actually trigger the crash. You can turn it into a test, and you can fix it. And eventually, after a while, it's going to be able to run for a bit longer. And I'm going to cancel my demonstration right here because I do not want you all to see the router crash. Oh, it just did. Interesting. I have a reproducing a case that I can reproduce. If I run this command, I can reproduce this exact test case with the bug. I can minimize it. It's going to take a bit, and it's going to figure out the smallest input it can give us so we can actually reproduce the bug. Super interesting. I'm going to keep this window open just in case it's not a demo and I actually crashed the router, right? And the last thing that I wanted to show you about fuzzing is right here. So this is even smaller, I guess. So I'm going to zoom in. This is a trophy case. The trophy case is a showcase of bugs found via FODS testing. Super interesting to have a look at. A lot, and I mean it, of crates rely on it to provide you with the most stable code they can. And you can see a lot of either security issue or panics or bugs that have been found by the FODSer. It's an extremely powerful tool. I highly recommend you to use it. All right. So in order to trust the rewrite, we need a common suite of test cases. Did I just unplug? Sorry. We need a common suite of tests that applies to both code bases. Ideally, you have started your migration by writing integration tests that apply to your previous application. Given this input, I get this output. Once you have what is called like a test harness or a safety net, it's going to become much easier for you to start the rewrite because you know you have acceptance tests. You know exactly how your thing is supposed to behave. And once it behaves as expected, git add dot, git commit -m done, git push, and you put it in production. Not quite, not quite. But we're getting there. Another thing that is very interesting, but that's more for the opsy people. Anyone familiar with Kubernetes? Wow, that's impressive. Honestly, I should just drop the mic. Everyone knows most of the things that I'm talking about. That's really amazing, by the way. Traffic mirroring is a feature that allows you to pretty much mirror all the incoming traffic to several places at the same time. It can be very useful. You actually send stuff to your production and you send stuff to the new. And then you can check whether the response actually has the same shape. Try not to do that with mutations, or try not to do that with the production database. If you insert rows twice, it might not lead to a great outcome for you, but you be the judge, I guess. Another thing that we do is validation with feature flags. It's something that we recently did in the router. We basically have some GraphQL validation that is running in JavaScript, and we rewrote that part in Rust. And in order to make sure that it actually behaves as expected, we have a bunch of feature flags that can be configured for the router, where you set validation to JS only, Rust only, or both. And if you have both, we can actually identify cases where it doesn't behave exactly as expected, so we can cover them and gain more trust. This is why the section is called How to Trust. It's not about bugs or not bugs. It's about others understanding that the level of quality you bring to the table is enough for them to trust you and your software. Tech is never about tech. It's about people. It's about them understanding how much you value the quality of the work and how much they should trust you. Okay? So feature flags, super useful. There's probably another way to test with that, but I might get to it later if I get enough time. The third one is how to trust we will not break production. Yeah, I just shipped my software. I'm very happy. Some SREs responsible for actually dealing with prod might not be too happy when they get paged at 3 a.m. on a Saturday after a couple of drinks. Okay, let's not do too much. Telemetry. There's one person right here who could talk a lot about telemetry. Yeah, I'm talking about you, Luca. I'm not going to dive into it too much. Basically, you can add observability using the various tracing, open telemetry crates that you get from the Rust ecosystem. It's a bit of setup, I'm not going to lie, but once you get it right, it's extremely helpful. Then you can feed all of that into your tiered environments. What I mean by tiered environments is pretty straightforward. Dev, staging, sometimes pre-prod that hopefully kind of looks like prod, but it's not quite the same, and you figure it out sometimes when your production crashes and you don't expect. And then production, okay? You test in lower tiers, you add all the features that you're gonna use in prod, and you observe the behavior, logs, spans, telemetry, metadata. And once you have confidence in the lower tiers, then the SREs are gonna come to you and say, hey, when do we ship it to prod? That's when you win. And dashboards and alerts. I don't have any recommendation as to how to set up dashboards and how to set up alerts. We personally use something that is fairly expensive. It's a brand that barks. I'm not going to give more details. That's probably enough. And the last thing that I want to touch on is progressive rollouts. There's a really great feature in Kubernetes that allows you to set up. So at the ingress, an ingress is pretty much what gets the traffic from outside and routes it inside to various applications. There's a features that allow you to say, I want to route 0% of my traffic to this application and 100% to that one. And then you do progressive rollout. You progressively turn the knobs, so you send 1% of traffic to your new app, and then 2, and then 5, and then 10. And if anything goes wrong, you just roll it back to 0. And you keep working on that, and you can do it in lower tiered environments, and then to production. That's how you do it. About progressive rollouts, there's one more thing that we use that is sometimes very helpful. There are features which are present in the router that were not present in the previous gateway because we iterated on that and we built new things on top of it. We also have a feature flag that is for clients using something that is called Launch Darkly. Do you know Launch Darkly? Cool. Launch Darkly is pretty much before you do something like A/B testing or something, you're going to call Launch Darkly. You're going to ask, give me the percentage or the ratio for this specific probe. And it's going to tell you, yeah, that's 50%. Okay, then you're going to roll the dice. And if that's below the 50%, then you're going to hit endpoint A. If it's above, then you're going to hit endpoint B. Now, what we're using it for is not for rollouts like what we said about Istio and turning the knobs to switch traffic from the gateway to the router. We actually use it as a flag that is called router in production. This flag is either 0 or 1. So the clients will know whether router is in production or not. If it's in production, they can use all the fun new features that we have provided. But if we need to roll back to the gateway, we can just set the flag. The clients are going to stop relying on features that are not available in the gateway, and we can safely roll back. That's pretty much what we are doing at the moment to make sure that if we ever need to pull the knob, we know how to do it. Doesn't mean that there's a bug in the router. It sometimes means that it's 3 a.m., I got paged, I have no idea what is happening, just gonna revert. It's not too bad. We'll see on Monday. It's just fine, okay? And that's pretty much it for me. If you have any questions, feel free to use this link or the QR code, which you hopefully took a picture of. And thanks, everyone.
Sasa, yes. Beautiful. Well, thanks a lot for giving the talk, first and foremost. Can we go back to the slide that has the Slido link? Thank you. Thank God some people had scanned the QR code, so we already have some questions.
Cool.
And in the meantime, you can enter others. So first one is from Amin, which says, so you showed before that you were invoking Dino from Rust, and he asks, is there any serialization or deserialization cost when you're trying to do Rust to JavaScript, JavaScript to Rust interop?
There is a cost. There is a cost to it. The reason why we went with that approach, well, there are two reasons why we went with that approach. The first one is that this specific step that is called query planning, which is kind of like, you know, in SQL, when you write explain plan, when you write a query, it kind of shows you what needs to happen to actually satisfy the query. That's pretty much what we do. We create a query plan with the sequence of HTTP or GraphQL fetches that need to happen to actually satisfy the incoming request. This query plan generation is a lot of logic. It's a lot of code, really. And in JavaScript, the way it's written is with a lot of circular references and dependencies. I don't know if you've done enough Rust to write trees and circular references. It's probably not the easiest way to start. The second reason why we chose to keep that part of the code in JavaScript is because the result, the query plan for a given query is always the same. So instead of spending like 6 months to rewrite that part for something that can actually be cached, it's just not worth it. So we went away and we were like, okay, what are the parts that are actually in the hot path that will make us successful? HTTP, input, processing, all of that, that's where it matters. The rest, we let JavaScript do the work, and we cache it. Doesn't mean we're not going to rewrite the query planner, as I hinted. It's something that I'm very excited about. But yeah, that's pretty much it.
Good. Related question. You mentioned at the beginning that you don't have to necessarily choose to go all into Rust, so you can adopt progressive rewrite patterns. If in this case, does the fact that you have two languages in the same code base actually increase the difficulty level of getting started with Rust compared to just doing a Rust code base?
That's a really good question. I think it does to some extent, because of course we need to create all the tools or reuse the tools that actually allow us to interface back and forth. But the good thing is that we could reuse the same code, and we have been able to lean on the same people who were working on that code and who actually understood what was happening, independent of what language it was written in. So that was certainly a plus. Another thing is that it really depends on the way you slice and dice the job to be done. I know that, for example, in Firefox, they started at the leaves. And what I mean by the leaves is that they didn't start with the core of the engine. They started with like the bits and bolts for networking or input processing, this kind of stuff. That's where the value is. That's where the safety is required, because you can't just parse garbage and expect that everything is going to be fine. And if you really think of the parts that you want to rewrite and you start small, then yeah, you will pay a small cost at the beginning, but it will then set you up for success instead of just rewriting everything greenfield, especially like for huge work, like years and years of work. That's probably not going to work out just fine. And the other thing is that while you are rewriting the small parts, the rest of the code remains in your favorite language or the language that you are used to, which means people can actually keep delivering value on top of it. And that's really the main point. You do not want to stop your project, stop your efforts for the grand rewrite. So it's worth it, in my opinion.
Okay. A few more questions popped up. Some are quite interesting. First one, so when you do a rewrite, obviously, you usually try to match existing functionality, but you're also testing the logic again because you're going through it, rereading the code, rewriting it. Did you discover any subtle bugs in the original version of the gateway? Or not so subtle? That's also fun.
That's a good question. We did find differences in behavior, and we did sometimes not know how to resolve it. What I mean by that is sometimes a test would fail, and we'll be like, is that a bug in the router, or is that a bug in the gateway? We are very thankful to be working in a GraphQL ecosystem, which means there's a specification and there's behaviors that are defined. I sincerely hope you have specification at work. Sometimes it's not the case. The good thing is that it actually starts the conversation. It's not about talking to other engineers. It's about talking to product sometimes. Do you actually want it to behave this way? It used to behave like that, but it looks odd. What do you think we should do? That's the right conversation to have. The other thing is that that's the sort of things that we kind of found by using fuzzing. Because we are comparing the output between the router and the gateway, sometimes the router would crash, and sometimes the gateway would do something really weird. So it kind of helped us improve the quality of our Rust and improve the quality of the previous application, which was still running and is still running at this very moment. So it's really a win-win. As soon as you start having this conversation, I'll go even beyond that. The reason why we write snapshot testing is sometimes that we don't understand what is happening in there. We give a bunch of input, get some output, we store it, and now we start refactoring it. You can't be scared of a part of your application. You are responsible for maintaining it. There's no way you can be like, I can't touch it. I don't know what it is. I'm super scared. I'm not touching this part of the code. No, it is actually your duty to understand how it works and refactor it until it works the same and you actually understand what is happening. So that's another really good way to have the conversation, understand your code base, be that in Rust or anything else, honestly.
One last question, and then we're gonna just let you breathe. So you mentioned at the beginning that you went with an approach of, let's look at the gateway, let's look at what it's doing, and where can we add the most value by rewriting a component, a module, a subset in Rust. What tooling did you use, or imagine profilers did you use to find out those portions? Like, how did you come up with the strategy?
So this happened before I joined. So I'm just gonna say some random stuff. Do not believe me. No, basically what happened is that one of the reasons why the company decided to switch to Rust is that we needed the gateway to scale better. It needed to process more queries. It needed to do a lot more. So we knew the limits and we identified the bottlenecks. And to be very precise in this case, basically we had a Node.js server, which is really good at I/O and async stuff. That's really great. But then there's a lot of dealing with JSON, traversing trees, doing some computation. This is CPU bound, okay? This doesn't work extremely well in Node.js. It has to do the work, it hogs the CPU, and there's no room to do something else. And at that point, we were like, okay, what is the most CPU heavy parts of the gateway? Well, query planning. Yeah, but query planning we can actually cache. Okay, what's the next heavy part? Well, gathering the HTTP outputs from all the subgraphs. So a query comes in, we make a bunch of HTTP calls, we gather the output, and we do a lot of mangling here. Okay, so this is the part that we actually want to focus on. Let's see what it would give if we use the web framework in Rust and started doing a bunch of JSON operations. Let's compare that. Let's see if we can optimize it a little. Let's see the difference. Okay, there's a huge perf boost. Let's go for that. And that's basically how it started. And that's pretty much the strategy. Identify, profile, and once you have profiled or identified the various places where you can expect great outcomes, you go ahead and talk to others because you don't want to do it on your own. And that's yeah, that's pretty much what we did. I think.
Well, that's one real question from the audience, which we're gonna take.
Sure. Thank you for the talk.
Sure.
You didn't talk about the interrupt between JavaScript and Rust. Is it WebAssembly, ABI?
Yeah. So, is it WebAssembly or ABI? So at the moment we're interfacing through Dino, and Dino is written in Rust. So we basically have a library that exposes Rust primitives, and it runs TypeScript within the runtime. What effectively happens is that Dino interfaces with V8 and isolates. I don't know if you're familiar with it, but it's basically going through the whole V8 pipeline under the hood. That being said, it's very interesting because parts of the router, there's a part that is called the Apollo compiler, which is basically parsing queries and doing validation, this kind of stuff. It also exists in JavaScript, but there are also clients using Kotlin, Swift, JavaScript or React or whatever. It would be nice if we didn't have to do all the work twice. So we are considering having like WASM support for this specific part so that people in other languages can actually rely on it. And there's like one source of truth, one implementation that actually satisfies everyone. And that is hopefully going to be fast.
Cool. Well, one last show of hand for Jeremy.
Thank you.
And we are going to have a 5 minutes break, and then we start again with the panel. So you have time to breathe, and we have time to set up. See you in 5. Hello, hello again. Ooh, that's powerful. If we get seated, we can start. Come up on stage. So, this is a panel about people using Rust in production. On one side, we have Jeremy. You have heard about him and Apollo GraphQL for the past 40 minutes, more or less. So I assume you're all introduced with Jeremy. On the other side, we have Bastian, which you might have seen in the audience, but probably haven't heard of. So let's start from you. Who are you? Why are you here? What are you telling us tonight?
All right. Well, first of all, nice to meet you all. Very happy to be here. Bastian, I'm the co-founder of Rayon. We're a startup doing a collaborative design tool for architecture and interior design. So basically Figma for architecture, you'd say. And we do use Rust a lot for the core engine of the app. So it's pretty much like a game engine that we use to render and to do all the computation for geometry. So that's basically what I do. And about me a bit, just to say that I have kind of an odd career because even though I have an engineering background, I didn't do much computer science at school at all. It was pretty much pen and paper at the time. And then I became a civil servant and I worked in public housing for 10 years. So I pretty much self-taught in computer science, which is kind of a testament that you can actually learn Rust late in your career. So don't hesitate to do that. And then I co-founded a first startup and I started to learn about tech. And I did this for 5 years before I co-founded Rayon.
Perfect. So we've heard before from Jeremy how the Rust Paris meetup in a way was his gateway into open source and also his gateway into Rust specifically. What was your journey to Rust?
Yeah, sure. So as I said, I kind of started to teach myself coding in 2015, somewhere around that. Started with JavaScript, classical, Node.js, doing web apps, stuff like that. And then I moved a bit into data science, especially computational geometry, and we're doing a lot of Python, and a bit also of .NET, C# because a lot of SDKs in the field of CAD is done in .NET. And at that point, Python was sometimes slow. So that a lot of Python know that. And usually the case is you rewrite a bunch of code in C and then use that in your Python code. I didn't want to do much C, so I started to look at Rust. That was my first experience. Unfortunately, at the time, we were doing quite complex algorithms in geometry, and they often involve data structures such as decel, double connected edge list, or a half edge, which you might know is not the easier structure to do in Rust if you're a beginner. So I tried that, and I was, okay, what is this? I have to use refcell, interior mutability, unwrap all the time. It really, really sucked. I was like, and then I ran it. Of course, I didn't use the release flag, and I was like, it's slow, it's bad. So I kind of gave up on it. But then I was, starting to think about Rayon and doing basically a vector graphic tools, very similar to Figma. And I was like, oh, okay, so how do you build this? I had no idea how you can build something like that. And the first thing, of course, you need to do is build your own renderer, because Canvas or SVG is not going to cut it if you have huge models. And in computer graphics, C++ is kind of the king language. All the libraries are in C++. Most of the legacy tools are in C++. But at that time, it was around, I think, 2016, 2017. There was a huge traction in Rust, and people were rewriting stuff from C++ to Rust. And I kind of stumbled upon a crate, which was called Pathfinder from Patrick Walton, you might know it, which was amazing. It was a tile-based rendering engine. And I was like, oh, I got to learn Rust to understand this. So that's kind of how I became interested in Rust. Then I saw the Lion crate from Nicolas Silva as well, super interesting. Then all the work from Ralph Leven in PGPU. So I was like, okay, this is it. I'm going to write it in Rust. So that's how I started in Rust.
I see. So one methodology note before I keep going for questions. That's still the QR code for the Slido. So if you want to ask questions, that's the preferred way. We're also going to take questions from the audience. If you prefer, just raise your hand. I'll see you, and then I'll send Marco with the mic at the right moment. Said that, so we heard before about Apollo, and we heard about, we use Rust because we are deploying a gazillion servers, and it makes sense to use something faster because we save on infrastructure, reliability, and so on and so forth. Said that, so we heard before about Apollo, and we heard about, we use Rust because we are deploying a gazillion servers, and it makes sense to use something faster because we save on infrastructure, reliability, and so on and so forth. what about Rayon? So you spoke about rendering. Why has that led you to Rust?
So it's a very good question, and I think it was some kind of a topic that was debated, like using Rust to basically compile it to WASM and to use that in the browser. There was a question: is this actually faster than well-crafted JavaScript? And it's a good question. It's not an easy answer, to be honest. A lot of people that have done benchmark can see that sometimes you can get the same performance if you write very well JavaScript. And I remember, especially, there were like a blog post. It was about should you rewrite on WASM, and it was, I don't remember the guy name. It was a very smart guy that basically took a library written in WASM and just rewrote it in JavaScript by using super smart ideas, and it was as fast. But the takeaway I got from that was you should absolutely use WASM because it was insane the level of expertise this guy had. He knew everything about V8, about SpiderMonkey. He knew, it was complete incredible hacks to get the runtime in the browser to go very fast. Compare this to WASM, you get very consistent performance across different devices, and also you get all the advantages of Rust language. So I thought about it, and I realized that to build a very performant design tool, probably going the WASM route was a good idea. And now I don't regret it. I think it's a good choice.
So basically you're saying that you can use JavaScript as the assembly of V8 and you can manage to get any performance, but it's actually much easier to get that out if you use WASM.
Yeah, exactly. I think the main point is if you're doing a design tool that is supposed to draw very large models, they're going to be made up of very small entities in very large number. And this is something that JavaScript does very badly. Because you get all those objects, they're very heavy in memory, so you need to use typed arrays and you need to destruct everything. So it becomes really hard to do. And contrast that with Rust, you get abstraction for free, you get control over the memory layouts, and you can just do it much simpler in a way. So that's one of the reasons I think it's quite important. And Figma had done kind of a debrief, because at the beginning, Figma, they were using C++, but they were using ACMGS. So they actually lived the transition to WASM, and they brought that they gained like 2 to 3 times in performance in CPU speed, which was quite impressive. So that was another argument that kind of convinced me to use it.
Okay, that makes sense. Let's take this a step further, right? So very often we speak about Rust as if Rust it's a thing, like a monolithic concept. But in reality, when you speak about Rust, you speak about Rust, the language, and Rust, the ecosystem. And depending on the use case, the ecosystem is more or less mature, more or less stable, more or less comprehensive, so to say. So let's go back to Jeremy, who's been sitting here very patiently. How was your experience at Apollo rewriting the router when it comes to the ecosystem? And the question specifically is about how much did you find that you could pick off the shelf and mostly worked compared to having to customize or having to write your own things or just becoming an expert of every single open source library that you were deploying? Which is an experience I personally had in the past.
Yeah, I feel you. Yeah, that's a good question. The way I behave at home or on site projects and the way I behave at Apollo are drastically different. When I'm on site projects, I basically go to areweyet.com. So are we web yet? And then I pick whatever is popular or looks fancy or is interesting. And then I start doing stuff. When you're working, for example, at Apollo, we actually package that stuff. There are people who actually rely on our stuff. We can't just ship random stuff and expect people to use it or live with all the quirks and bugs that could be found. So it's not the same mindset at all. That being said, there's like, what we build is pretty much an HTTP proxy that you can use in your infrastructure. There are HTTP bits on which I think the ecosystem is extremely mature. And there's then a GraphQL awareness layer, which is the one that we bring into the table. So this raises a lot of interesting questions, by the way, like build versus buy. What is my domain? What is it that I'm working on? I'm working on GraphQL. I'm not working on HTTP per se. HTTP stuff, I'm going to use Hyper. I'm going to use what was it that we used before? Warp. And then we switched to Axum because there's this Tower RS ecosystem of composable services, reusable services. We're going to build on top of that. No questions asked. Everyone's using it. We're going to use it. Tokyo. Should I use Tokyo? There are other runtimes, right? I really enjoyed other runtimes. I enjoyed them in my side projects, unfortunately, because most of the ecosystem relies on Tokyo. I'm not going to take any chances as to my supply chain or my ability to move fast later. So yeah, most of the time it's either us reusing libraries that are widely adopted and that we are fortunate enough to understand because we've used them in the past. I'm thinking of Fred for Redis, for example, the Fred client. Tower, tracing, OpenTelemetry, my God. It's really great. It's hard to get right, but it's there. Everyone is using it. Everyone is relying heavily on OpenTelemetry. We're going to use OpenTelemetry, no questions asked. That's pretty much the rationale or the decision. Can we be there for our customers if we use this tool?
See. So basically the message I'm getting is you only use old improved technology at work and then you run zigs on the edge with SQLite replicated for fun.
Yeah, pretty much.
That's pretty much the economy.
Cross-compilation with Dig is awesome.
Okay,
yeah.
Cool. So let's move to Bastion instead, because obviously you have a very different domain, right? So on this side, we're looking at HTTP proxying with some level of GraphQL magic on top. On this other side, we're looking at rendering engines and multiplayer experiences in the browser. How is the ecosystem for that in Rust?
So I would say that it's getting better a lot, but it's not the same as C++. So you do get that trade-off. If you would write a rendering engine in C++, you would get a lot of things that you don't get in Rust. So yeah, I would say it's not that great, but it's still very good. And also the community is amazing, and you get cargo, so you get way better management of your dependencies. So we do. I mean, in our case, that's kind of a core business. So we are okay rewriting stuff from scratch. We are okay writing our own renderer. We do use some libraries. For example, the whole engine is based on an ECS, so Entity Component System, and we use a library for that. We didn't build our own ECS. But I feel sometimes the move we do is we start with an open source project, and very rapidly, due to performance and domain constraints, we might move it then, we might fork it and make it our own. We did this, for example, for spatial data structure. We use acceleration through quad trees, or in this case, an R star tree, which is a kind of data structure that we use for that. And initially, we used a library for that, but then in the end, we wrote our own. But it's very useful to get that little push at the beginning, and then you can understand better and you can improve. So I would definitely say that the ecosystem is not as great as other languages, for sure, but it's still very good. And I think you should choose Rust for stuff that is very business centric in our case, so it doesn't really matter that much.
Okay, that makes sense. Let me ask you a follow-up question, because you touched on ECS systems. How much of, because obviously there's the graphic rendering community and then there's the game development community in Rust. How much of this ecosystem actually overlap and you're able to reuse, or are you a little bit on two different points of the spectrum and the requirements are too different?
So there's definitely an overlap here. And it's true that the gaming community and the gaming libraries are way more numerous than people doing CAD. CAD is quite a very niche subject. And most CAD software were built in the 90s in C++, so you don't really have a huge community around that online. But yet, what I've seen is it's also that you get a lot of libraries that are open source and they work, but to some extent, it's and I think of course people are doing that in their free time. It's often very easy to start a project, much harder to finish it. So it's the last finishing touch sometimes that are not there. Let me give you an example. Text rendering. And if you're familiar with computer graphics, that's kind of the boss battle of computer graphics, being able to render text very well. There is a bunch of crates trying to port stuff like half-buzz or other shaping libraries into Rust, but it's not completely there yet. You would in C++, you would just get that. Another example would be Boolean pass operation. So the ability to do intersection operation with paths made of cubic Bezier and line segment and arcs or even conics. Very hard problem. To my knowledge, there is no Rust crate in Rust that does that well. You only had them in C++. So that's kind of the example where it's a bit lacking with the legacy language, I would say.
I think that makes sense. There's also a new company started, which is called KittyCAD, which I think is something similar for hardware design. So CAD is back in fashion in the 2020s, and we might get more Rust software for CAD. Some of the things you mentioned bring me to a follow-up question I wanted to ask. Obviously, as we said, open source sometimes has done the first 90% of a problem, hasn't done the second 90% of solving the same problem. And you fork and you write your own. Do you consider contributing back, or do you consider open sourcing your own solutions? How do you navigate that question?
So first of all, I want to make clear that I absolutely love open source, and I think open source is like
we're not questioning you.
amazing, and it got me into Rust. So one of the goals at Rayon is really to contribute back. So for example, those libraries I mentioned that are lacking, we definitely want to build them and open source them and just put them out there for free. It's just they take the time, and we're just very small right now. But that's definitely on the roadmap. We're definitely going to do that, and I think that's the way you enrich the ecosystem and make it better all along.
I mean, it's also true that sometimes some components that you fork become so customized that it's really not useful for other people to use them. So it's on a case-by-case basis, I guess.
Yeah, that's very true, and that's something we see a lot in Rust. It's like some libraries that do have this constraint that they're gonna have nice ergonomics for their external users. If you build that into your product, you don't have that much constraint, so you can maybe make it more performant if you make a different trade-off. So for sure, that's also an explanation why sometimes you need to fork the open source library to make it a bit more domain adapted and a bit less flexible, especially in web. Because one of our constraints is that we need to have a bundle size that is not huge, and a lot of Rust libraries, they do compile to some quite large binaries, especially due to monomorphization of the generic types. So we try to not use that too much and try to find other solutions.
So you compromise dynamic dispatch at runtime in exchange for smaller binary sizes. Okay. Same question this time for Jeremy. What's the Apollo GraphQL approach to open source upstreaming, contribution in general?
I mean, that's where we're from. Apollo started with Apollo client and Apollo server. It was all in JavaScript. It used to be open source. That's the reason why we're here at first. If there wasn't open source, there would probably not be Apollo. That being said, we're operating under slightly different constraints here. The first one is that the Apollo router is a library that is exposed in crates.io, which you can basically pull down and use. In order for a crate to be published to crates.io, it cannot have Git dependencies. So we can't fork unless we publish the crate. So that leads to very interesting discussions and questions. One of them is, for example, if you have a specific use case in mind or something, you're like, should I open a pull request upstream? Is that going to be accepted? Is that even something that people need? So it really starts conversations around how much can I give back to the community, and what are my constraints? What is my domain? Is the feature that I'm trying to work on generic enough so that it works? Another nice constraint that we have is that sometimes people's release cycles don't match ours. You have a bug fix, you have a patch, but it's going to take a while to actually deploy. And I say it as I maintain Bastion. It's probably something that hasn't had a lot of love in the recent month, if not years, because I just don't have the time to work on it as much as I wish I could. And it has constraint. Like, people have lives, they just have to deal with it. And it's kind of hard. So yeah, the trade-offs are here, the conversation are here. Basically anything that we can bring back, we do. You will see a lot of pull requests opened, and most of the teammates are basically coming from open source. So we have a very strong open source culture. And then there's the trade-off. Is that build versus buy? Is it something that we need to own so we can actually move it in the direction that we need to? In that case, well, we'll write a crate if we need to. But it's a lot of engineering time, honestly. Sometimes you just bite the bullet and that's it.
Oh, that makes sense. Let's take some questions from the audience. So I have one from the slide and then I have one from the room. Let's start from the Slido one. Everybody wants to know if you use GPU acceleration or web GPU, and it has been asked 3 times.
So we don't use web GPU because it's not well supported enough today. So we just use plain old vanilla WebGL in the render engine. And we don't, we are in the midst of rewriting a new renderer, and it's still going to be in WebGL. I think we have to wait at least probably 1 year, 2 years before we have enough browser support to make it viable in a product. So, but it's definitely there on the roadmap, and I think we should see some gains from it. So we will definitely look into it.
Like if you didn't have to support a wide range of browser compatibility, is that a target you use today? Do you think it's not mature enough?
Sure. Because one of the bottleneck that we have is tessellating some curves before we need to render them, and since we don't have compute, we cannot do a proper pipeline on the GPU, so we do it on the CPU. That's a real performance bottleneck. So moving that, being able to move some of the operation we do on CPU to the GPU, it will definitely be a net win. So I'm really excited about web GPU. I'm really excited about it. But when you have a commercial product, you need to support the vast majority of browsers, especially us, because our clients, they're not tech savvy. They're architects, they're people in real estate. They don't have the latest device, the latest browser, so we need to support quite.
What's the oldest browser you support?
So I would say like modern browser. So we don't support Internet Explorer.
Everybody has a line they don't want to cross.
We support Safari though, so it's already a good effort.
Cool. Let's take the question from the audience.
Yes. First of all, thank you for this very informative discussion. I do have a question regarding the use of Rust for writing the rendering software, especially in the browser. Raf, you brought up Raf Levine about his work on this. I guess Rust is very special for writing this kind of software. One route is using ECS and basically abstraction away using graphs and all of that. You basically have vectors and then you index into them, and it's fast. But it has some issues when dealing with paths, for example. So there is an issue there for using Rust. So what was your experience by using this choice of Rust for writing this kind of software, especially that it's very hard to do self-referential structs and other mistakes.
So I'm very happy about it. I think if people are using Rust to do that, is because C++ was the language in which you would do it, and it's a system language. Rust was kind of thought to be able to replace some C++ and bring in safety to that. So and also because Servo did a lot of work there, and I think that drove a lot of people to it. But coming back to us, I'm really happy with this, because if you look at rendering, I think ECS and rendering are 2 different problems, because the ECS is more like for the business logic of the engine. Rendering, it's basically about getting some primitive pass text points and being able to translate that to some data on the GPU that can draw. You don't really need an ECS for that. What you need though is the ability to do very fast computation on specific small structure with a very good control of the layout in memory. That's very important because you're going to have a hot loop where you're going to get a lot of data, and cache miss are very costly. You need to be aware of that. You need to also be able to use the least amount of memory you can. So Rust gives you the ability to use a byte if you just need a byte, or to use an F64 if you need precision. That's super important. You don't get that very easily in JavaScript. So for those reasons, I think it's very nice. It works really, really well. And also for all the other reasons that it's very nice, because you get, if you look at rendering, it's quite complex. And the compiler, it's a huge help to not make too many bugs, too many mistakes. So for that, you can come for the performance, and then, as Jeremy said, you stay because you have that safety and the ergonomics of the compiler.
So we talked about, are we GUI yet? More than a few. I have a different question, which this time goes on the other side, which is, are we web yet? So the question is, obviously Rust is suitable for high performance, constrained at scale, et cetera, requirements, type of web services. But do you think it is a viable or recommended choice if you're doing a simple CRUD, for your definition of simple CRUD?
I would very much love to have your answer on this, because I know you have opinions on that. Yeah, maybe next time. I think we are there, to be honest. A couple of years ago, I was not that confident, sometimes because of... Look, I think the way async was introduced was great because it allowed for experimentation and all of that. But then it became something that we did not want it to become. And it was kind of hard to reason about the various crates in the ecosystem and kind of fights between those. It's something that I did not quite enjoy personally. That being said, the state that it is at, it's pretty standardized. It relies on a couple of crates. Like, everyone is relying on pretty much the same standards, which is great. It allows us to focus on the same things and improve the ecosystem. That's one thing that I really enjoy. And specifically for web stuff, like there's one example that we have in the router. So the router needs to support hot reload. What I mean by that is that while you are taking requests in, you need to be able to update your configuration, like update the whole stack, but not drop connections. You need to gracefully keep dealing with them while accepting new ones with the new configuration. This is the sort of things where you need like finer grained control over what is happening. Now, at that point, instead of using the Axon primitives, you basically reach out to whatever's below, you bring it up, and you write your loops yourself, and you actually deal with it. So that's something that I really, really enjoy. I think we are web now. I think we could do better, especially for the ergonomics, because I don't have a PhD in math, and warp was too hard for me, for sure. But otherwise, I think it is stable. It works really well. Still have some HTTP2 hiccups that I would like to deal with, but otherwise, it's honestly looking good in general. The thing that we can work on is ergonomics, but I think you have a pretty good idea about that.
It's not my panel, so we're not going to talk about that. Let's get that question.
Thanks. Software people love principles, and one we have is use the right tool for the right place. Rust has branded itself rightfully as a system programming language. So the web is not exactly the place where I would expect it to blossom. And I don't feel that I have heard much justification or sufficient justification of why using that there. I love the language. I try to apply this. I feel that most of the people repeat this principle ad nauseum, but never applies it. Use the right tool. No, actually, I'm gonna use what is cool for me, and this is what generally we do. Let's be honest. So do we have better justification in your cases? So I don't understand that if you have complex geometric operation, obviously you would need this, but AutoCAD is not running on the web. 3ds Max is not running on the web. Why do you need your app to be run on the web?
A business plan question.
Yeah, no, that's actually a very good question, and it's kind of the whole premises on which Rayon is built, which is that the problem with CAD software or legacy software that are desktop native apps is that it's very hard to share your work because people need to have the software installed. And if you look at architecture, for example, it's a very collaborative process. You have the client, you have the architect, you have the engineers, you have the contractors, people that are going to build the stuff. they're often in different companies, so they're not going to have the same tool. So the fact that you can do it in the browser, it's a huge gain, because then you can just share a link and people can just open it, and they all have a browser, and they can just access it. So it's kind of this paradigm. So that's why we think it's super important. But where you're absolutely right, it's if you look at from the performance angle, it's much worse. Like, it's way harder to do than do a native app. So we make that trade-off. We think, okay, of course the web was not made to do those kind of software, but the gain that we have by this kind of the browser is the OS paradigm is often it's enough for us to say, okay, let's try to make this in the browser, exactly like Figma did, exactly like Google Doc did, and we're seeing this more and more. But it's kind of a trade-off you need to make.
I actually have a follow-up question there. So obviously we've talked so far of using REST for doing, well, for targeting WASM, which then you're deploying in the browser. That doesn't necessarily confine you to the browser, does it? Like, nothing prevents you from a technology stack in the future to also offer a native version of what you're already deploying towards Chromium and Firefox.
Yeah, sure. And that was actually one of the idea we also had by using Rust, was to say, yeah, we probably for our super users, we're gonna definitely build a native app at some point, because it's more powerful. You can access more features of the GPU. You can do way more stuff, and having the core engine built in Rust means you can reuse that, so it's very useful. And also, one thing I didn't talk about is that we also use Rust on our backend. We built a multiplayer backend, and the very nice thing is that we can just reuse the code from the client to the backend. And if you have built engine for multiplayer in games, you know that you need to run a lot of the same stuff that you run in the client in the backend to check for invariants or stuff like that. And by using Rust, we can reuse that very well. But we could have done that with JavaScript as well. I mean, in Node.js, but we get performance as well and all the advantages that you mentioned.
Yeah, it's the holy grail of the one stack. Which actually brings me to another question I wanted to ask you before. So we said, okay, you're using Rust in the backend, you're using Rust in the front end for all the canvas rendering and so on and so forth. But you're also using TypeScript in the front end, are you not?
Yeah, sure. And that also goes to your question. One thing I feel that Rust is not very good at is building UI. And something that is the web and the DOM and JavaScript is very good at is building UI. So the whole UI of Rayon is done in a very vanilla React TypeScript app, and only the core engine is in Rust. And to give you an idea, I actually looked at the number before coming. We're just shy of around 200,000 lines of code in Rust, and we have a bit more in TypeScript. So it's like a half and half. So for sure, and if we had to build the UI in Rust, and I know some companies have done that, even for the web, that would have been extremely painful, for sure. So I think that was the right trade-off.
And also, it's a very common strategy. Like, I have seen it deployed in multiple companies, especially the ones that do native applications or like multi-platform applications, to have their core business logic, the fat client, so to say, written in Rust. And then, they're doing Swift, and then they're doing Kotlin, and then they're doing TypeScript, depending on what they're targeting. So that is definitely a pattern that is seeing more and more adoption, and quite successfully, to be fair, at least from the people I've spoken to. So, different question that was coming from the audience, but once again, speaking of rendering engines, how are you doing the multiplayer part?
So it will be a long talk to describe, but
short, abstract.
Yeah. So if you want to go in detail, so basically we use a system that is very similar to Git. And maybe you're familiar with a company called Rossi Corp. They do something called Repliclash. I mention it because they wrote a very nice paper illustrating their strategy, and it's very similar to ours. So if you want to look it up, they're much better than us at that. But we build our own. So yeah, basically the idea is that you have a state that you can diff very easily, and this is where ECS actually is very nice, because for those that don't know, ECS is a very simple idea where you just have entities and a bunch of components. So it's a very flat structure. So it's very easy to know what has changed. You look at each component and you can have a new value. So we can diff the state very easily, and then we send all those diffs to a backend, and the backend is like the central authority that decides, okay, this is the value. And then the problem becomes, how do I eventually converge on all the client to that same state that is on the backend? So this is where you need to rebase, you need to do stuff that is precise, especially when you put the undo redo mechanism on top of it. But that's the core of being a multiplayer engine.
Which is also fun, or it sounds fun, a particular type of fun. Now, obviously, we've talked at length on Rust at Apollo, Rust at Rayon, but in a way, and this is true what he was saying before, like developers sometimes like their tools, and so they follow the tool, and then the tool determines the problem. And so I'm aware of several people who are trying to break into the industry using Rust as their main programming language. So in a certain way, you are living the dream, so to say, of this audience, because you're working with Rust full time. And so the question I ask you as the hiring managers, or in any way people who are building teams that use Rust, and so interview and look at profiles, what suggestions do you have for folks that are looking for Rust jobs, and what do you look like? What do you look for in a profile for those positions?
Okay, so that's a very good question, because it's true that it can be quite hard to have some experience in Rust, professional experience. So what I would recommend, and this is something we always look for, is to just build your own project. So it's quite hard to do because you need time for that. So you have a job, how can you do it? So the two ways we have done it is, first, people that have built their own open source project in Rust. Obviously, that's the best, I think, stuff to do, because you learn the language and you can show off your work. We can look at your code. So that way you get past the screening immediately. And the other thing that we've done is people that haven't done no Rust whatsoever, but are very strong in another language, sometimes, for example, C++ or TypeScript. And then we make them come on board in a role where they can do a bit of both. So in our case, since we have half the code in TypeScript, we had some engineers that actually started with the TypeScript stuff and gradually worked on the Rust side. And now they can do both, which is very valuable to us. And for C++, my experience was that people very strong in C++ can learn Rust very fast. So that was not a huge problem. And we had people like that come on board.
What about you, Jeremy?
I'm gonna say half-lie because open source is pretty much the reason why I landed a job using Rust. Back then, I had a choice between learning Go and learning Rust, and I kind of enjoyed talking to Rust people, so I started doing Rust, and one thing led to another, and it landed me a couple of jobs, so that's awesome. That being said, I know that Apollo, for example, when we hire, we are looking for people who can actually understand the product and can actually talk to other and get a broader understanding. Rust, we can teach. That's no problem. There was this, I don't know when it was released, but the Google material that helped.
Comprehensive Rust.
Exactly.
Yes.
There's a lot of high quality resources on how to learn Rust. We can certainly teach Rust to people, and the best thing is that if it's wrong, it's not going to compile. I feel really great having junior engineer pushing stuff into production in Rust, no problem. So that's probably not what I'm looking for. I'm looking for people who are able to ask the right questions, talk to the right people, understand what kind of ecosystem they're working within. And yeah, teaching, yeah, you just put them in a team with great engineers who want to share knowledge, kind of works.
Yeah, I guess you made two good points there, right? First one is that a person that doesn't know how to use Rust, worst case scenario is ineffective, is usually not dangerous, which is not necessarily true for all languages. Can tell a lot of stories about Python. The second, though, is interesting because obviously you say Rust we can teach, But I also know the folks that work at Apollo GraphQL, you have a stellar Rust team. So you're starting from an extremely strong well of Rust expertise. I also would say Rust we can teach, if I had that lineup in my backend team. So true, but I would caveat that it depends on the company you're applying for. I love my answer to this question as well, with previous experience, having hired a lot of Rust developers. And it goes back to what Bastien was saying. You have usually two skill sets. The one is the domain knowledge, and the other one is the technology knowledge. And as long as one of the two is present, the other one can be filled. So, if you are strong in the domain, then you can be taught Rust. If you're strong in Rust, you can be taught the domain. If either of them are not there, then it's very difficult to get started. Is the pizza arrived? I have no idea of concept of time. I can keep asking questions for a long time. Wait.
I don't see it, but I think just go on for a bit longer.
Okay, so one question from you in the front. Marco is away, so keep my microphone.
Thank you. Have you have to convince other people to use Rust? To me, in Merit, once you start using it in your personal project, it's kind of obvious, but it's hard to convince some people, the team sometimes. And my solution was to change my job half a year ago. What was your experience?
If you can't bring Rust to them, you go to Rust. That's a good strategy, but let's hear their answers.
So I'm not sure I have an answer, because since we were using Rust from the get-go, but we do have some engineers that only do TypeScript and don't really learn Rust, I think mostly because they don't have the time. I've not met people that were no, not interested, don't want to learn it. Especially from people that only know JavaScript and TypeScript, I feel it's such a complementary, additional language to have in your tool set that is so different from JavaScript, and I would definitely recommend to look at it. So no, I didn't have that kind of problem.
I had that problem. I had to dial it down a little bit because I was just so in love with the language that I couldn't stop talking about it, and it became a bit not aggressive, but a bit boring to others, I guess. The strike force is here. I think there are two things to acknowledge. One of them that I spoke of before, which is when you're at work, you're here to deliver stuff. You're here to add features, fix bugs. And rewriting everything in another language because you think it's cool is probably not the best move, right? Even use the right tool for your job, honestly. That's it. You are shipping stuff in Python or JavaScript. The whole company knows how to use it. Should we switch because the language is more appealing or a bit faster? Probably not. That's not where the value is. Doesn't prevent you from having side projects or doing a bunch of cool stuff and socializing it, going to meetups and everything. Sometimes it means changing job. And to that extent, there's the ecosystem is the industry is pretty interesting because on one hand, you have people who are excited about Rust, who are willing to find positions that use Rust. And on the other hand, you have companies that say, I can't hire anyone who does Rust. What is happening? And now there's this really weird spot. And I think it comes from having strong senior engineers who join these companies or even consultancies that help them with a boilerplate, we are going to help you set up your projects correctly in order to use Rust, and we are going to teach everyone and infuse the knowledge for a couple of weeks, maybe month, so that then you have the stable basis, you've picked the right libraries, you picked the right ecosystem, and you have the right knowledge to be successful. Once they have that, they will probably be in a better position to hire more junior engineers or do more with that. But we need to help them bootstrap it. And I mean, by we, I don't mean we as engineers, but we are as business people or consultants. That's what we are here for. People want to, we just need to give them the push and help them start it.
This is what I call the Rust cold start problem, where people are I want to get started. Well, we don't have any Rust experts, and we don't know where to find them. It's that can be solved. And yes, you can also talk to me for what Jeremy was saying before. Said that, I think we have a question from the far back.
Yes, hello everyone.
Hey.
So we speak a lot about back and front, but I've seen that, Jeremy, you've been working a few years ago with Rust on embedded systems. So I would like to have your feedback. I know Rust It's a long time, 3 years with Rust, but I would like to know what is your feedback. I don't know if other people here are using Rust on our embedded system, but I think it's a huge thing now at the moment.
Wow, that's a good question. That's one that I unfortunately don't have enough knowledge to answer. I did work on embedded systems. I worked on the e-bikes, which was extremely fun. So protocols that were close to what you get in the automotive industry, for example, that's really great. I see strong signals of people who really want to invest time and energy to actually use Rust in general. I see a lot of value here. By that I mean the guarantees that you would get from the language are pretty good. With that being said, for safety critical systems, the language, the whole language is not certified, and we don't have the full history as much as C or Ada. Is it Ada? Ada? So it's such a situation. It's slowly gaining traction in non-critical systems, and in embedded systems it really shines. There's like no stud. You can use it in pretty much anything. There are, like, it has a super low footprint. The binary is a bit big, but it has a super low footprint at runtime. And even like you can strip the binary. There's a lot you can do. So I'm very optimistic, and I don't know if you follow or see what Ferrous Systems have done recently with Ferrocene, among other things. We are getting there. There's parts of Rust that are being, how do you say it?
Certified.
Certified, yeah, really. That's it. There are part of Rust that are being certified. They are not yet certified to actually create, to build spaceships and rocket with it just yet. But we are slowly starting to see it gain traction. And even I saw a blog post a couple of weeks ago from Volvo, who start using it in their systems, but also in their embedded systems, for example. So it just takes a lot of time, I guess, to actually get the traction. But certainly a space I would watch for. Yeah.
I mean, we're not in outer space yet, but we're getting into automotive. So Volvo is an example. Renault published a paper quite recently in the same direction. I know of experiments at other places that haven't written about that publicly, so I'm not going to mention them. But yes, getting Ferrocene out, and so getting a tool chain that is certified for a certain level of usage is at least making a lot of conversations happen. Then we'll see in the next, I think, 12 to 18 months what those conversations actually become. There was one question there.
Hi, on Rust, we have a rather large code base, and so obviously we have compile time issues. We have two main solutions for that. The first one is to reduce genericity. It has a quite big fallback. So the way we do it is we do a non-generic inner function. You have a generic stuff, you do your genericity and non-generic, like this, only this thing. This comes with a lot of boilerplate. I don't know if you have a solution to reduce this boilerplate. The other solution that we have is to split code into multiple crates, which enables more parallelization and compilation time. This has another fallback, which is you don't get warnings about unused code anymore because you have to put public your structures and functions. Do you have a solution to that? And do you have a third idea on how to optimize compile time?
That's a really good question. The snarky answer would be I would wait for Foster Than Lime's next blog post. He'll probably figure it out. I think we read the same one about genericity and the inner function, which is actually a good idea. One thing that we started doing at Apollo at first was to avoid derives that we wouldn't need, for example. You know, you use like derive debug because sometimes why not? Derive clone because why not as well? And then you end up like expanding, generating a lot of code. That being said, what we try to focus on at the moment is more aggressive caching and reusing of whatever has been compiled before. I'm talking about Circle CI artifacts. I'm talking about SC cache, for example, and Cargo Chef, but I think someone else is able to talk about it as well.
Yes.
So yeah, reuse as much as you can. Unfortunately, it's a pain. The first thing that I wanted to say about reducing boilerplate would be macros, but if you add macros, then you're in an even worse spot because, and even if, like if it's proc macros, then you need to recompile it every time a user changes their code. So might as well want to avoid that. I unfortunately don't have a really relevant solution for that. That's one of my pain points as well. Anyone else?
No, I don't have a solution.
I can give you some pointers, and based on like we've done this on some code bases. Like step one is breaking it down into crates. The issue with that is, as you mentioned, you don't get any code unused warnings. There are some things that can help with that. So some of the tooling that he mentioned at the beginning around code coverage, you can use that to an extent also to look at lines that are never exercised, and that can be a way to recover some of that. The other thing you can act on, obviously, is aggressive caching at everywhere, in every place, whatever you can cache. The other is throwing more compute at the problem, especially in CI and also in laptops. It's true that ARM laptops are much faster at compiling REST than x86 64 laptops, and this is just a fact. So any M1, M2 is going to have a much better developer productivity that you get on any other kind of laptop. And the third lever you can use is linking. So trying to understand what linker are you using, and also how you're structuring your tests, and if that is generating a necessary linker load. But we can go into details. You grab me afterwards, and this is one of my favorite topics, which is why I'm switching from questionnaire to answerer.
Just on the derives, do you have a tool to detect unused derives?
Not aware of that existing.
That's a good idea for a weekend project. It's
a few weekends projects, probably.
Yeah, maybe a few weekends.
I mean, depends on how much RAS compiler contributions you've done in the past. But I don't want to put a ceiling on that.
I have tens of domain names I've never used, so what's one more?
Keep the economy going.
Yep.
So I think we are nearing the end. I saw some pizzas in the background. So I'm going to ask you one last question, and then we're going to wrap it up. So we spoke about business, we spoke about REST usage at your respective companies, what drove that, and a bunch of other, very serious people questions that I've been asking for 30 minutes plus. The question I like to close this kind of panels with is, let's forget about all that. So let's assume you have an amount of unbounded free time that you can spend, and you can work on any project you like, which might be programming related or not. What would you be doing?
Wow, that's a tough question. So I have children, so that would be probably my project, I would say. And coming back to technology, one of the cool things I always wanted to do was kind of build stuff, and I've dabble very far back building stuff with electronics and Arduino and stuff like that. So probably that I would want to do some stuff like that, and use Rust on in Rocket. So yeah, building a robot with my kids, that would be a nice thing.
Well, I don't have kids. So I do have a bit of time.
That's also a good project, making kids.
So you have a home lab.
Yeah, exactly. Yeah, I could do that. No, I think I would probably teach others. I used to joke that I did Rust because I was not smart enough to do C++. I think it can be taught. I think it's great. And there's a lot of people that supported me when I started doing open source and all of that. If I could give back some of that by spending time with people, trying to help them understand and learn that, I'm much more interested in the human aspect of the Rust ecosystem than the actual code. So yeah, that's probably what I would do. And you have my credentials. If you want to reach out, DM me. If you have any ideas, questions around mentoring or whatever, just hit me up.
Sounds good. Well, that was a wrap. Give them a show of hands. They've been here for a long time. And obviously, we don't want to be between you and the food. But thanks again to Qonto for hosting us today. I hope you had a nice evening, and we can stay a little bit longer for some chit-chat. Bye-bye.